In this video, we're going to be talking about linear relations. And what a linear relation is, it says when points on a graph lie in a straight line. It is called a linear relation. So you see an example of a linear relation over here. Every one of those points are an identical straight line. And since it is a relation, remember that relations can be represented with a set of points. It can be represented with a table, and we could do it with a graph. We could do it with an equation, which is what they've done here. Linear relations can be represented by an equation. For example, the equation of the graph over here at the right can be written as x plus y equals 8. And that's what we're going to be talking about is how can I take a line and write it as its equation. Okay, standard form. Linear equations are often written in standard form. Standard form is ax plus by is equal to c. This one is actually written in standard form to where your a value is 1, your b value is 1, and your c value is 8. A, b, and c are integers, which means that they can't be fractions or decimals. Your value of a, now this is all depends on which book you're reading, but most of the time your a value has to be a positive, has to be greater than or equal to 1. And the GCF of a, b, and c is equal to 1. Don't have to really worry about that. But the biggest thing is you have, it's reduced is what that's saying, and you don't have any fractions or decimals. Okay, it says on this next part, write each equation in standard form. Again, you just need your x's and y's on one side, and you need a constant on the other side. So x stuff, y stuff equals constant stuff. Everything looks good except for the leading coefficient needs to be a positive. So you can very easily take care of that by taking everything, both sides, and multiply it by a negative 1. So it'd be a positive 5x, a negative 6y, and a positive 12. You're in standard form now. Okay, just make sure your leading coefficient's a negative or a positive number. Now what I did there is, again, I just multiplied everything by negative 1. Now the next one, to get this in standard form, I need my x stuff and my y stuff on the same side. So let's move this 2x and it becomes negative 2x. The y is still positive and it's equal to 9. We're going to do the same thing. This number out front needs to be a positive. So we're going to take both sides. We're going to multiply them by negative 1. That changes this to 2x, a negative y, and a negative 9, which pretty much it just changes the signs of everything. This one's nearly in standard form already. We're just going to move our 24 over so that we have our x and y stuff together, and that's equal to a positive 24. Now again, a reminder, I might have told you this before, but anytime you have an equation, equations can be reduced the same way the fractions are. If you have the fraction 3/6, then you're asked to reduce it, then you divide top and bottom by the same value. You divide top and bottom here by 3, you get 1/2. You can do this the same way. We're going to divide every term by the same number, and I think 3 is your GCF here. So that leaves you with 3x plus 2y equals 8. That would be standard form. We're going to reduce it as much as possible. Number 4. We want our x stuff over there with our y stuff, so minus 7x becomes positive 7x. The 7y stays positive as well. We see that this is reducible, so divide everything by 7 gives me x plus y equals 1. Final answer. Number 5, we don't like these fractions. Let's do something to get rid of fractions. Here's how you do it. Find a least common multiple between your denominators. And this works for any equation that you're ever going to solve. A common multiple of 4 and 3 would be 12. What we're going to do, we're going to take everything, left side and right side, and we're going to multiply by that multiple, least common multiple. And look what happens. When you distribute it here, something special happens. We're going to do 12 times 3/4. Cross cancel leaves you a 1 and a 3. You get 9. Notice there's no more fractions. 9 over 1, so that turns into 9x. A positive times a negative is a negative. Now we got to do 12 times a third. Cross cancel leaves you with a 4 and a 1. That would be 4 over 1, which is 4. So if you were to multiply an equation that has fractions by the LCM, then you get rid of your fractions. Then on the other side, we have 12 times 1, which is 12. And that is finished. Number 6. X's and Y's need to be on the same side, but if you'd like to, let's go ahead and get rid of this fraction. Since 6 is your LCM, we're going to multiply, and you can actually just write it around the whole equation. We're going to multiply the whole equation by 6, every term. 6 times 1/6 gives you 1x. 6 times y gives you 6y. 6 times 2 gives you 12. So that's no more fractions. We need our x's and y's on the same side, so move these y's. That'd be x minus 6y is 12. Again, here's your checkpoints. The leading coefficient, this 1 out here, needs to be positive. It is. All of your coefficients need to be non-fractions, non-decimals. They need to be integers, and they are. The GCF, there should be no value that will divide into 1, 6, and 12 besides 1. It doesn't need to be reducible, and it's not. So therefore, that is your correct answer. And don't put that 1 because it's understood to be there. The next one, or next up, slope-intercept form. Probably the most important form of linear equations that you're going to learn. Linear equations are often written in slope-intercept form. Slope-intercept form is y equals m times x plus b, or now that we know function notation, f of x equals m times x plus b. Okay, same thing, y and f of x is the same, where m is the slope and b is the y-intercept. So what do we mean by slope? We've done slope in previous classes, but let's go over it again. Slope is a constant rate of change. It tells how slanted or how quickly your line is changing. The constant rate of change between points. Think rise over run. There are 4 types of slope. Sketch them below. Your 4 types of slope are positive slopes. Now these are types. Negative slopes. You have zero slopes, and you also have undefined slopes. A positive slope is an uphill slanted line. From left to right, it goes uphill. A negative slope slants downhill. A zero slope is a horizontal line. It has no rise. It runs, but has no rise. And then finally, an undefined slope is a vertical line. There's your 4 different types of slope, and we'll go over those again as we progress through this. Okay, now slope-intercept form. If you don't remember, if you can write a line in slope-intercept form, y equals mx plus b form, you're able to look in front of the x and know what the slope is. You're able to look at what's being added or subtracted, and you know what the y-intercept. If you don't remember y-intercept, that's where a line crosses the y-axis. So this one here is written in y equals mx plus b, to where the number in front of the x is your slope. So this line has a slope of 2/5, and the number that's being added or subtracted is your y-intercept. So what that means is, it says write the equation in slope-intercept form. It already is. Then let's graph it. So this line, if you don't remember, here's how you do it. It has a y-intercept of 7. That's the first thing you put on your graph. 1, 2, 3, 4, 5, 6, 7. This line is going to cross your y-axis at 7. This line has a positive slope, so that means it's going to be an uphill line. So from left to right, we need to make sure that this thing slants uphill. The way that we're going to do that is we're going to use our slope to get other points on our line. Slope is rise over run. So this line is going to rise 2 and run 5. So from this point, I've got to go up 2, and then I'm going to run 5. To get it to go uphill, that would be to the right 5. However, that's not really going to fit on my graph. So another way of doing it, you can also rise negative 2. You can go down 2. But to get it to go uphill, when you run 5, makes you go 1, 2, 3, 4, 5 to the left. Now, if you take those 2 points, connect your dots, that would be the line y equals 2/5 x plus 7. Y equals negative 1x plus 2 has a slope of negative 1. If there's no bottom, we put it over 1. It has a y-intercept of positive 2. And again, f of x simply means y. So my line is going to cross at positive 2. I want a downhill line, so it's going to slant this way. So we're going to rise 1 and run 1. So you can go up 1 or down 1. So if you go up 1 to get it to go downhill, I'm going to left 1. Continue doing that over and over. Or if I were to go down 1, I'm going to go to the right 1 and continue doing that over and over. So my line would look something like this. See if I can draw that. We put arrows on both ends, denoting that it goes on forever. We connect our dots, saying that we can actually plug in fractions and decimals as well. Next one is written in standard form. Now, to get it in from standard back to slope-intercept, here's going to be your steps. Step number 1, let's move our x back to the other side. We now have 3y equals x becomes a negative x. So that I have something to divide by, put a 1 in front of it. And that's the one time that you do want to list that 1, because now to get rid of this 3, we've got to divide by 3. And I put that 1 there to give me something to divide by. So now you have y equals negative 1/3 x. You see your slope. Negative 15 divided by 3 is a negative 5. So you have a slope of negative 1/3. You have a y-intercept of negative 5, which means your line crosses at 1, 2, 3, 4, negative 5 on the y-axis. You want it to be a downhill line, so make sure that you remember that when you're doing your rise and run. So if you go up 1, you rise 1, run 3. If you go up 1, you're going to have to go left 3 to get that downhill. Do it again and again. Or if you went down 1 to get the downhill line, you would go right 3. And you can continue doing that over and over. So the graph y equals negative 1/3 x minus 5 looks like this. Arrows on each end. Now you can always, from the get-go, you can still do your table of values. You could plug some x's in, find the y values that go along with it. That's another way of graphing these, but that's much easier. The next one, let's get this in slope-intercept form. Very easy. Let's take these two values and move them over. Then your y is by itself. 4x becomes negative 4x. We always write our x value first because again, this is in y equals mx plus b form. Minus 1 as you move it over becomes positive 1. So this has a slope of negative 4, which we write over 1. So we have a rise and a run. You have a y-intercept of positive 1. So this is going to cross at 1. We're going to, negative slope would be a downhill line. So we're going to rise 4, run 1. So we're going to rise 1, 2, 3. If we go up 4, we're going to go left 1 to get a downhill. You can nearly do it again. If you're going to go down 4, 1, 2, 3, 4, you're going to have to go right 1 to get your downhill. 1, 2, 3, 4, and 1. And there's the equation or the graph of y equals, let's scroll back up, y equals negative 4x plus 1. Okay, vertical and horizontal lines, we kind of actually hit on that a little bit last section. Vertical and horizontal lines are extremely easy to graph. Here's all you have to remember. A vertical line will always be x equals a number. To find out what that number is, look at where it crosses. 1, 2, negative 3. The equation of this vertical line would be x equals negative 3 because every point that's negative 3, 1, negative 3, 2, negative 3, 3, at every point on this line, the x value is negative 3. The equation of a vertical line, or excuse me, a horizontal line, vertical line is x equals, the horizontal line is going to be y equals. And you simply look and see where your line crosses the y-axis. This line crosses at 1, the equation is going to be y equals 1. So a vertical line, x equals number, horizontal line, y equals number. Okay, parallel versus perpendicular lines. Again, hopefully this is going to be a review, but the slopes of parallel lines are always going to be the same or equal. The slopes of perpendicular lines are opposite reciprocals. So example of perpendicular would be like 2/3 and negative 3/2. One of them will be positive, one of them will be negative. That's what we mean by opposites. Reciprocals will be inverses of each other. Okay, determine if these lines are parallel, perpendicular, or neither. Let me zoom in a little bit. So pretty much we're just finding the slopes here is all we're doing. So let's get this in slope-intercept form. Move your x term, gives you 5y equals 10x becomes a negative 10x. Divide everything by 5 to get rid of this 5, and it gives you y equals negative 10 divided by 5 is negative 2. 5 divided by 5 is 1. So my slope is negative 2. The second line, let's get our y, let's see, we move our 16 over, and that gives me negative x minus 16 is 2y. Now you don't have anything to divide by here, so let's put a 1 there. Divide everything by 2, and that gives me negative 1/2 x. Negative 1/2 x minus 8 is equal to y. So my slope here is negative 1/2. So I have negative 2 over 1, and I have negative 1 over 2. But be careful, because when you're dealing with perpendicular, they have to be opposite and reciprocals, meaning one positive, one negative. Here, both of them are negative. Now, they are reciprocals, but they're not opposite reciprocals. So these would be, let's see, neither. They're not parallel nor perpendicular. They are neither. They were nearly perpendicular. Okay, number 14. Steps to getting y by itself. Move the 8x over. It becomes negative 8x. Always write it first because you want it in mx plus b form. Divide everything by negative 6, and you get y equals negative divided by a negative is a positive. Take 8 over 6 and reduce it. Divide top and bottom by 2. Positive divided by negative is a negative, so my slope here is 4/3. Second equation, this will be pretty easy. I've just got to divide by negative 3. However, my right side, I don't like the way they wrote that. Let's rewrite it as negative 4x plus 9. Divide everything by negative 3. And you get y equals negative divided by negative is a positive. Positive divided by negative is negative. You're not concerned about the y-intercept. You're just concerned about the slopes. Both of these lines have a slope of 4/3, so these lines would be parallel. The next one, number 15. One thing that you can do, you can go back to something we did on standard form a while ago, and you can clean this equation up. You could actually go through and divide everything by 8, and that gives you negative 1x, a positive 1y equals 0. 0 divided by 8 is also 0. It doesn't change that, really. And then the last step, just move your minus x over, and you get y equals positive x. So the slope there would be 1. The second one, what I like doing here is, since it's a minus y, let's move it and at the same time move the 4. So the 4 becomes minus 4, the negative y becomes positive y. So you have y equals x minus 4, so the slope is going to be 1. So these lines, since they have the same slope, would be parallel. Number 16, x equals 2 and y equals 2. Now let's remind you what these graphs look like. X equals 2 is go over to 2 and draw a vertical line. That would be the graph of x equals 2. Y equals 2, you go up to 2 on your y-axis and you draw a horizontal line. That'd be the graph of y equals 2. A horizontal line and a vertical line would always be perpendicular. Which, by the way, you can also, from geometry, use the symbols for parallel and perpendicular. There's the symbol for perpendicular. The symbol for parallel would be two parallel lines.